Okay, so a warm welcome everybody to the Artificial Intelligence and Machine Learning session at 2R62. People are keeping joining, so we'll just wait a couple of minutes. It is my pleasure to introduce you to two main speakers for today, who are Anthony Bellotti, Associate Professor at the University of Nottingham, and Matias Khan, who is a Data Science Capacity Building Manager at HM Revenue and Customs. So in the meantime, people are joining. Just want to show you a slide that because this is the last day of the conference, probably you've seen quite a bit. So just to keep a housekeeping, we recommend you position the speaker in the top right corner where you can see the red box now in my slide. You have two options to get in touch with us, either a chat or a Q&A. Please use the chat only if you have like some technical issues or you want to introduce yourself. Differently, if you have a question for one of the speakers, please use the Q&A box. At the same time, remember that you can vote the questions, so you can upvote them. And also during this presentation, there will be a series of polls, but be aware that if you're joining by browser and don't have Zoom installed, this won't be available to you. And finally, a video of the session will be available after the conference and it will be communicated. So I'm going to leave it now to Anthony to start the session.
Hi, it's Shaquille. Apologies, I'm having broadband issues today, so I've dialed in. Just to start the presentation, I'd just like to say thank you to my co-presenters today and panelists from the AI Task and Finishing Force group at the OR Society, and also Validate AI, Tony Bellotti, who will be presenting with me. This presentation has been inspired by conversations within the community around how we ensure that AI systems are still valid and trustworthy as a result of the issues of population drift coming out of COVID-19 as a dramatic shock to the system. So next slide, Tony, the Validate AI initiative. So Validate AI now is a company and a movement, and the reason why it came about was there were various conversations going on between academics and practitioners that from one perspective celebrated the democratization of development of AI. And, you know, we all know the fantastic opportunities through open source, through data access, and through algorithm development. There's many platforms to do that now. But one of the concerns we were having is, although it's very easy to deploy these systems, are we sure that the systems are working in a manner that we would expect? So that's in terms of safety, in terms of, you know, the ethical considerations of deploying these models, because these models are being deployed in health settings, in financial services settings, in security settings, and indeed from my home department, Revenue and Customs, tax, there are tax implications as a result. So the group, which initially was formed from academics from Oxford University and Imperial College, and myself, we had an inaugural conference in November 2019 at the Royal Society, and we were really pleased to have speakers from Google, Twitter, the Office for National Statistics, etc. And the purpose of the conference was to really consolidate what are the main issues to grapple with when we validate AI systems and we try and embed trust in what we deploy. As a result of that conference, we launched our first paper, and that's available on the validateai.org website. And what that paper did is it teased out the themes of the conference that the speakers from different sectors and from different parts of academia were talking about, and predominantly it was about how we measure the stability of AI systems, how we ensure interpretability in terms of the buy-in from our customers of these models, and also what standards and frameworks do we adhere to. So Validate AI is very much about bringing together academics, industry, and government, and following this notion that's been talked about of the triple helix effect, whereby these three components, when they come together, can really make great strides for kind of a nation or for particular problems within sectoral contexts. So, following the conference in November, we were all really pleased with how it went, and we were progressing various streams of kind of deep dives on topics that were talked about at the conference. And then the pandemic came around, and it really made us think hard, okay, these issues that we've talked about around validation, how do we now have to consider them in the context of AI validation? And so if you move on to the next slide, Predicting in a Crisis white paper. So we all appreciate that the main concern for governments has been the well-being and the livelihoods of individuals. AI systems, as I mentioned earlier, affect every aspect of our lives now, and that situation will just increase. And what we need to think about is, given the shock to systems and the shock in terms of the way we report on data, the forms of input data that we receive, and the outputs that we're actually modeling against in terms of supervised models, how do we tackle the issues resulting from all these different shifts in the underlying data and what we call population drift? Now, Noel Quinn from HSBC, the CEO of HSBC, he describes COVID-19 and the shock as unprecedented. And bear in mind, we had the credit crunch in 2008, and this, it's agreed, surpasses the implications that were had from the credit crunch. So, we are in kind of a really challenging time in terms of how we address these issues of misalignment and instability. So really, we believe that one organization isn't going to be able to grapple with and tackle these issues. So how can we work collaboratively as a community? So next slide. So in terms of the key challenges for AI systems, as I say, the community conversations and the discussions are key to finding the right solutions. There's two aspects to this in terms of AI system. One is in terms of the maintaining of systems that we already have in place. And the other one is about new developments. Okay, we are considering in our organizations, we are constantly considering new applications of AI. However, the notion of AI systems in terms of kind of their relevance is based on the future looking like the past. And certainly what we see from COVID-19 is the future doesn't particularly look like the past on which the data is gathered and we develop systems from. So the challenges in terms of maintenance are around measuring what the level of instability is. And if our systems of measurement identify that there is misalignment, how do we address those misalignment issues? And thirdly, if we're confident that the systems are working at this point in time, how can we mitigate the risks of changes in the landscape, such as economic, political, environmental changes that may well impact on our AI systems going forward. So, as I say, the issues that we're grappling with are around maintenance of existing systems and considering whether the time is right to develop new systems, given the scenario that the future doesn't look like the past anymore. Next slide, Tony. So as I say, the white paper that has gone out, so at the moment the white paper has gone out on a consultation to various groups, and we've been engaging with the likes of the Turing Institute, SAS Institute, Edinburgh University, other government departments. And what we would like to do once we've completed that consultation is share the paper more widely, and I'll explain how I can inform people about that. I'd just like to thank Professor David Hand and Tony for contributing and writing this paper. And I'm going to move on to Tony now, who's going to talk about the three aspects that I mentioned around monitoring, the remedial action if there is instability and a need for recalibration, and thirdly, what test measures you could adopt to ensure robustness into the future. So thanks, Tony.
Okay, thank you, Shaquille. I'm having some slight problems with, okay, it's fine now. The slides were jumping backwards and forwards. So, okay, hello everyone. So this predicting through a crisis paper was really a kind of survey of what existed out there, if anything, to help people think about how to deal with their models through a crisis. So what I'm going to do in the next 10 minutes is kind of just give you an overview, a very brief overview of some of our findings. So we start with the concept of training a machine learning algorithm. So we start with some historical data, which you take as training data to train our machine learning algorithm, which is then used as predictive analytics and decision support. But typically we think about this training data coming from some distribution, so call it H for historic. Now what happens during a crisis, or what do we think might happen? Well, we imagine that distribution of the population is going to shift. And okay, we're used to thinking about maybe small changes in population over time, but we're expecting some major shift in the population distribution from H to F. So the question here is, how does that shift from H to F affect our machine learning system? So we can think about areas of F, which would be the new situation through or after the crisis, and there will be some segment S, which is in F, which has not been very well represented in the historical data H. And so obviously if the machine learning algorithm wasn't given data from S to train on, we can imagine it's going to perform quite badly on that segment. So we can imagine that there's going to be some areas of the data where we get bad performance. So what can we do about it? First of all, can we measure it? Can we do anything about it? So if we do, well, we certainly know H, our historic data. If we did know F, we could measure and compute the difference. And you know, that's a way of monitoring what's happened. So we can use divergence measures to compare H and F, or within, for example, the credit risk industry, that would be a population stability index. But can we know F in advance? Can we know what's going to happen through and after a crisis? Is there a way of estimating it? Well, I think maybe things are not quite so bad. So if the crisis follows the same route as maybe a previous crisis, then maybe that will give us a clue to what's happened. Or if the crisis in one country follows something similar to what happened in another country in the past, that will give us some clues. Along with that, the second bullet point, or the arrow point at the bottom there, if we have some reliable economic or behavioral models, then this can also be used to give us some clue about F in the future. And in fact, yesterday's session on analytics, there was a very interesting talk about building economic models through COVID-19. and economists are using some rather imaginative methods and new data to do that. But it could be we're in a situation that the crisis is very unique, and we really don't have no way to get an estimate that we can trust. So we have to deal with a situation where we may have some estimate, but also a situation where we might not have that. So let's think if I do have an estimate, I call it F star of F. So here my diagram's getting a bit messy. So I started with historical data. F is going to be the true situation, and then F star is what my estimate says it's going to be. So if I trust my F star to be reasonably close to F, then I can do something. And so the first one idea, this is only one idea from the paper, is augmented testing. So you can take your data from H and modify it so it looks like data from F star. And you can do that by either resampling from your test data that you got from H, or you can reweight it so that it looks like it comes from a distribution F star. And once you've got that transformed or reweighted test data, you can run tests on the data to see how your machine learning algorithm performs in that updated situation. So I'll give you a very simple example. Supposing historically there was 4% unemployment rate within my data, and then after the crisis, my economic models suggest that could rise to 12%. Then I can modify my test results based on that, the change in that distribution. So I can either reweight all unemployed people by a factor of 3, say, or I can resample. So I'll go down the reweighting route. So you can see that table at the bottom. I have 1,000 data points, and in the original test data, there was 960 employed and 40 unemployed. And in the original tests, when I first built the machine learning algorithm, I had mean absolute error of 0.1 for employed. Because I have fewer examples of unemployed, I have a higher mean absolute error of 0.5, which gives an overall test mean absolute error of 0.116. And then after augmentation, the column at the very far right, I can reweight them. The reweights are 880 to 120. And then I get a higher mean absolute error of 0.148. Now, whether that mean absolute error means a disaster for this model would come down to interpretation and the business requirements. Now, okay, so that's one approach to monitoring and deciding how your machine learning or model is working. But we might want to think, well, what can you do about it? What sort of solutions, remedial solutions are there? So I want to give you an approach taken called from the credit risk industry called augmentation, and this is well known in credit scoring and known as a reject inference method. But the idea here is the same as augmented testing. I'm going to reweight my training data this time so that it looks like it comes from a distribution F star rather than H. So in this case, if I have a lack of unemployed people in the historic data, I can reweight it in the training data so that it has more influence on how the machine learning algorithm is estimated. So this way I can rebuild my machine learning algorithm so it's suited to data that I'm expecting to get during the crisis. And interestingly, this is a topic in machine learning community itself, which is called domain adaptation. I haven't actually seen domain adaptation actually addressing crises, but certainly the methods that are developed in domain adaptation can work here, because domain adaptation is all about machine learning algorithms built on one set of data and applied to a different set. And there's lots of other, so there's this reweighting technique, but there's lots of other techniques from this this area of the machine learning community. Having said that, the final bullet point, you might find that a total rebuild of your machine learning algorithm is expensive. You have to go through the whole rebuild and revalidation of the algorithm. So an alternative, which is cheaper and maybe will do what you want, is to recalibrate the algorithm based on the new distribution F star. And it's not very different, but you're keeping the same machine learning algorithm, you're just building a layer on top to recalibrate the outputs, and if we're thinking about outputs as probabilities. So here we have an example. So here we have some probability calibration graphs, and I apologize because I've committed the cardinal sin of not labeling the axes, but basically the x-axis is the predicted probabilities from the model, and the y-axis is the observed probabilities from data. And what you want to do is, if your model's working well, they should calibrate. So the blue line there is if everything's working perfectly. And you can see on the left graph, when I first built this machine learning algorithm under under data H, you can see that the graph fits quite nicely. So that's quite nice, but then once I move to F star, it starts getting a bit skewed, the middle graph. But I can apply a linear transformation to get that back into place. A linear transformation is based again on reweighting on the change from H to F star. I think I'm gonna have to go a bit faster because I think I'm running out of time. I'll quickly talk about, so another way of monitoring and thinking about the robustness of machine learning, a scenario test. So you remember I talked about this segment S, which I think is underrepresented in the historical data. Well, I can use that S or other scenarios, I call that scenario, to test the machine learning algorithm and see how bad it is just for that specific area of the data, because it may be that overall the machine learning algorithm is working okay, but that for that particular segment, it may be performing quite badly. And if you think about it, that may be a rather sensitive segment. It could be the segment of older people or a segment of people of a certain racial group. So you'd want to make sure that's your model's performing well in those groups. Okay, so this is something which is well known. So scenario testing and stress testing is related to this. Now we come to the situation is, so what if you tell me you have no way of estimating what it's going to be like through and after the crisis? So you don't trust any estimate of F star. What can you do? So the sorts of approaches that seem to be taken is the three here. So one, you can revert to a simpler predictive algorithm. So instead of your very nice but complex machine learning algorithm, perhaps you go back to a linear model. The second approach is to keep your machine learning algorithm, but apply some conservatism to the predictions and decisions that it's making. And the third approach is to use expert human judgment to override or supplement what the algorithm is doing. So I'll talk very briefly about each of those. So why would we revert to a simpler predictive algorithm? Well, there's a general thought that linear models are more robust against distributional changes. And there's a reason why that would be, because we know complex models tend to overfit, and in particular, they might overfit the characteristics specific to a certain point in time when you've got the historical data. And there's no way you would know that, because you can only test for overfitting in time, because that's the only data you've got. So it may well be that your complex machine learning nonlinear model is overfitting more than a linear model would. So during the crisis, maybe you can revert to a simpler model. And to plan ahead for that, it's probably a good idea, lots of organizations do it anyway, to take a management approach to models such as champion challenger. So you can have your machine learning algorithm as your champion model in production, but you have some challenges that you're monitoring through time with the champion that can come in and take over from the machine learning algorithm if you feel that you no longer trust what the machine learning algorithm is doing. Conservatism is a very popular approach at the moment in credit risk, which is an area I'm interested in. So the idea here is you keep your models like a loan approval model, but you basically make conservative decisions on it. So a loan approval model will basically say whether someone gets a loan or doesn't get a loan. So what you would do is you'd maybe make it more risk averse so that it will give out less loans, just to make sure that you're under what's an unmeasurable risk, really. You'd at least try to control what's happening. So I give some details on the slide, but I think I'm running out of time, so I'm going to press ahead. So that comes back to Shaquille. So Shaquille, do you want to talk a bit more about the early actions from AI practitioners? Okay, it looks like Shaquille's dropped out, so I'll keep going. What we want to do is to make sure that what organizations are doing is making sure that they're putting in place monitoring systems which are rigorous. So they have, so for example, I know, you know, I'm sure Shaquille doesn't mind me saying, HMRC, they're very rigorous about their approach. They have a handbook which checklists all of the monitoring that needs to be done, and they have, you can have dashboards so that you know, once you've deployed a predictive analytics model, you know what it's doing. The second bullet point there is additive AI systems. So the idea here is if you find that your machine learning algorithm, like a neural network, is suffering after a severe population drift due to a crisis, it's actually quite difficult to replace it or replace components of the neural network. You can't take a neuron out and replace it with another one. But if you have an additive AI model, which is, you can think as kind of in segments, you can take one chunk out, or if it's like a linear model, you can take one coefficient out. And it does, you know, if it's a particular coefficient on a variable which has changed a lot, then you could take that out and still run the model. So AI systems that are designed as additive or modular will be such that you give you an advantage during a crisis because you don't have to replace the whole thing. So you can, we talked about this, so you can combine expert and data-driven approaches. So you can keep your models, but you have expert judgment in-house to give you some sort of, some sort of feedback and some sort of update on what the machine learning algorithm is doing in case it performs anything badly. And the final thing, stress testing. So this is about the robustness. So make sure that you can stress test your existing system to see whether it is able to deal with or predict through to a future risk. And that is something you can plan ahead with your system in terms of monitoring. Okay, so we haven't, as Shaquille said earlier, we haven't actually finalized the paper on predicting through a crisis yet. We're still working on it. If you'd like to be notified about the release of when the release of the paper will be, please send an email to contact@validateai.org. So it will have more details on the things we talked about today and more. So it'll have lots of different ideas through and a survey of ideas in the paper. Okay, so these are some references from the Predict Through a Crisis white paper. So now I think we'll come to the panel. So what we will do is we will each introduce ourselves. It looks like we have, so I'm Tony Bellotti. I'm Associate Professor of Computer Science at University of Nottingham, Ningbo, China. My background is I do a lot of work with credit risk and in machine learning. Shaquille Khan unfortunately seems to have dropped out from the session, so hopefully he'll make it back at some point to answer questions. So what I'm going to do is ask each of our panelists to introduce themselves. I notice, unfortunately, it looks like Professor Richard Vidgen isn't here with us today. So maybe Michael, you can introduce yourself.
Yes, thank you, Tony. Hopefully you can hear me.
Yes, it's very good.
Okay, hi everyone, I'm Michael Mortensen. I'm an Associate Professor in Digital and Data Science at the University of Warwick. So the main areas I'm looking at is artificial intelligence, obviously, things like deep learning, machine learning, computational statistics, and also a range of other analytics types approaches. But we're combining that with things such as cloud native computing and disruptive digital technologies. So that's my sort of academic work, but also in my commercial projects, working in a similar sort of space, so kind of straddling between some of the AI and data science stuff, but then also some of the more digital and software engineering space. So a few trends, or 3 trends that I've seen working across those areas, and I think it directly speaks to some of these issues that Tony's been highlighting in this presentation, and indeed for this panel. The first of which is sort of AI everywhere. Formerly, AI was often embedded inside software solutions and in a sense having quite a small role. As we now know, algorithms are everywhere in our lives, and AI is starting to become everywhere in our lives and actually making important and sometimes sensitive decisions. We saw obviously the fallout from the A-level and GCSE algorithm, and whilst that was not AI, it kind of shows the impact that the algorithms can have in our world. The second trend I'm seeing a lot of is this idea of automated AI, which is software solutions that are building AI models themselves. So things like Data Robot or IBM Watson, you probably put in this category, and the increased use of that kind of thing. And thirdly, where there are more technical expertise at an organization, I'm seeing a trend towards AI being the preserve of people with a software engineering background, not necessarily from an analytical or mathematical modeling kind of background. So why am I interested in this topic? And I'll come back to how that ties in a moment. I thought it was a very interesting presentation on modeling in a crisis. I think a lot of these ideas also extend out to modeling in situations where we have high degrees of uncertainty. And I think history tells us the way that we deal with it, and also some of the ideas Tony was sharing. We need to have a good set of domain understanding to really be able to customize these models. So Tony talked about drift models and different scenarios. We need to really understand what that scenario might be, because it's not naturally present in the data necessarily. And also many of the skills involved in uncertainty modeling. I'll bring in just one example from my own work, just to illustrate perhaps how this transfers over into uncertainty. So one of the things I'm currently working on is a project which is designed to be able to detect human presence inside vehicles and inside buildings using software-defined radio. So we send out waves essentially and try and pick up human presence. And we're treating this as a convolutional neural network, an image recognition problem. So the way we built the model is to run physical experiments and put people in different scenarios, send the waves out to them, and then try to make a prediction if it is a person inside that building or whatever it is. What we're held back with is that you can only capture so much data. The data is expensive to capture. These experiments are time consuming to conduct. So the way we're trying to resolve that, and I think it adds to some of the examples Tony gave, is running much smaller experiments. So if we can model the effect of temperature on the human capture, and if we can model the effect of being close to a body of water, for example, in a smaller, cheaper kind of fashion, we can use that to augment the data we currently have, create new data that represents those changes. Now, again, and tying into some of the examples Tony had there, I think, and my main point is, to do these kind of methods, and I think these methods are critical for models that are robust to uncertainty and robust to dealing with crises, as was discussed. You need to have some of these skills in domain understanding and uncertainty modeling. I fear, going back to my 3 trends, going back to automated AI and software engineers becoming the main authors of AI systems, that there is something of a skills gap in that community. Conversely, I think talking to this particular room and looking at the OR community in general, I think that's something that OR professionals tend to be strong at. So there's a lot of work in capturing domain knowledge, for example, through things like problem structuring methods, and obviously a lot of work into uncertainty modeling. So I'm particularly interested in how perhaps we can combine the learning and experience of these separate communities to build the kind of robust models that Tony has talked about. And that's me, thank you.
Okay, thank you very much, Michael. So Matias, can you give us a quick overview of an introduction and your interest in this topic?
Yeah, good morning, everybody. My name is Matias Khan. I'm a senior research manager working in BT's applied research team. I work in a research theme that looks after service and operational transformation, and specifically my team is very active in the production management and optimization space. So we use a wide selection variety of OR and AI optimization simulation approaches to tackle specific, if you want, challenges with the human resources across BT. So clearly I am a practitioner. In my team, we develop and downstream solutions in the planning space, in the scheduling space, in the simulation space. So we produce solutions that are used day in, day out for the management of resources in BT. So it's, for instance, engineers or desk-based agents. Some of the work that we've done in my team includes, for instance, predictive models that look at the overall situation and then make predictions what the work stack might look like over the coming weeks. What service levels are we expecting to hit over the coming weeks? And there are a lot of inputs going into this. Other models might include predictions of what fault volumes might look like under certain weather condition, under certain work stack and environment conditions. We also run simulations and predictions what kind of bandwidth at the core network level we might actually that we are likely to see based on how individuals, so you and I in our domestic environments, how we consume videos, music, how we interact with the internet. So clearly the current COVID crisis had a significant impact on the inputs and often therefore also on the outputs of some of these models. For instance, if you look at the bandwidth requirements, a large proportion of the workforce used and continues to do work from home. So we see very different shapes of bandwidth requirements. Similarly, if you look at the work situation in a company like BT, social distancing rules have led to a very different situation in terms of the balance between provision and fault in our work stack. We have scaled back to a degree less important work to focus on keeping the national infrastructure alive and up and running. And that has led to a very different situation in many scenarios. So we're really interested in making sure that what we have deployed is still fit for purpose and that it reacts even under very unusual circumstances in a way that is reliable and accurate. But I'm also interested from a second point of view. The drift that was previously mentioned doesn't just happen in a crisis, it happens all the time. If you look at deployed AI systems, they are quite good at the point when you deploy them, and then over time they become a little less accurate. Sometimes you have back-end system changes that nobody really recognizes as important, but that somehow impact your AI models. So a lot of what we're talking about here, accuracy, how we make sure that everything is still working, applies to normal day changes as well. So I'm quite interested in the concept of contracts almost for AI models, where we clearly define under which circumstances do we actually consider the AI models to be valid, to be accurate. What are the triggers when we have to review whether we should deploy a different one or should fall back to a simpler approach? And how do we actually ensure that we have those simpler models in place? In industry, AI models don't suddenly appear out of nothing. You often had previous working approaches much simpler, but they were proven over many years. So those could be, for instance, fallback options that in a crisis you can rely on. So I'm also interested from this second aspect. Thanks.
Thank you very much, Matias. So we can now start the Q&A session. So we have about 20 minutes to answer questions. So I encourage, there's a few questions already coming up, so we can talk about those. I'd encourage you to ask some other questions if you want to. So maybe we'll get started. So I'm going to go through the questions in the order of the priority that I can see. So they're prioritized according to people voting for them. So the first question, so some of the questions are quite a little bit technical. So how can you validate recalibration? So I don't know, do either of the panelists want to talk about that?
I mean, it somewhat depends on what is meant by recalibration. Is it meant to be when a model has drifted, or like Matias was talking about, performance has diminished, in which case I say you validate recalibration on the same way as you validated the model in the first place. Does it now perform better? And does it perform better with the newer data as opposed to the older data? If we're talking about recalibration, perhaps into a space of uncertainty, it's a very good question and a very open question. Exactly what, because we're by definition talking about a space where there is little ground truth. And again, that's really where I think I see a big role for sort of domain experts and people with experience of modeling uncertain situations can come in and help.
Yeah. One aspect that might well be referred to here is that sometimes it takes quite a while before the actual outcome is known. So you might have a requirement to deploy a model for a different situation. However, you won't have, if you want the actual truth available for several months before you see it there. And what you can do there is, for instance, try to look at the training data set and select it in a way that from historical data, maybe from a time period that you originally didn't consider, that mirrors your current situation more closely. I think there was somewhere a comment or a question around if you had prior crisis situations, why isn't that actually already in the data? Well, often the data, so for instance, in a situation like BT, we might look at the last 2 or 3 years worth of data as an input, but the crisis might well be much further back. So in a crisis situation, you might then look further back and decide what is a more appropriate training data set, and then use the calibration based on that, historical data point.
I think so.
Okay, thank you. I don't think I've. Sorry, go on, Michael.
I was going to say another thing. Just if it came in, there's potential for the use of things like simulation models in order to validate where there is not the data hasn't arrived yet, as Matias is talking about.
Yeah. So I don't have anything to add. I think you said everything I would have said as well. Okay, thank you. So so we move to the next question. So really good presentation. Thank you. I'm in credit risk modeling industry and really interested in the augmented methods and reject inference methods. Where can I get to know more about your research on this? So again, maybe Matias, do you want to go first?
Well, I think the white paper that you were referring to in your presentation is a good starting point, because it's a nice summary overview, and there are quite a number of initial references there that will take you to this. If you go on the web, there are also a number of case studies that actually talk about this that you can find. So I would suggest as a starting point the white paper, and then follow up from those references.
Michael?
Yeah, I don't have anything particularly to add. It's not necessarily entirely my area, and I'll bow down to the work. Sure. Paper and so on. I think
so the only thing I'll add is actually there's from the credit risk zone, which is where I come from, there's not that many papers actually on augmentation and reject inference. You'll find 2 or 3. So authors like Jonathan Crook and Jonathan Banasek and David Hand. I know that there's papers by them. There may be others. I apologize if I haven't mentioned them. There's not a great deal. I haven't actually researched in this area. I just know about it. I teach it. The augmented method, it's also worth looking at this domain adaptation topic within the machine learning community as well, because they also talk about lots of different methods to consider different distributions from your data.
I'd maybe just add one thing that sort of comes from another part of the machine learning community that could be relevant in this space, which is transfer learning. The idea that one model can train another model. So perhaps there is another domain or another place where you have got, and perhaps goes into the next question, where you have got some of this data that's not currently in your data set. So maybe that other model can help train your model is the concept.
Yeah, okay, thank you. So let's move to the next question. So how would you recalibrate or test a challenger model if the outcome is long? For example, defaults within 12 months. So I think we've got a lot of credit risk people here. So defaults. So if you want to model defaults within a 12-month period, how could you recalibrate or test a challenger model in that situation? Any thoughts, Michael?
I think, well, we did touch on this somewhat already, and I think Matias gave some good examples there. I think that actually there's a role for a lot of the methods we've talked about, potentially things like agent-based modeling as a way of testing hypotheses, if you like, or going back to older data sets, or indeed finding other data sets that you can apply transfer learning from, or other models you can apply transfer learning from.
Okay, thanks. Matias?
Yeah, I think I referred to it in one of the earlier answers. One point maybe that we haven't massively referred to. One of the big buzzwords in AI at the moment is the concept of explainability, and a lot of the models deployed lack somewhat that element. So doesn't necessarily answer the question, how do you recalibrate an existing model? But in the future, we might well move towards models that have a stronger focus on the explainability aspect, because even if you're in a different situation, they still provide you, or would provide you, with an element of why they have come to a decision. And then you can bring in a human, for instance, to sense check those explanations and whether they still make sense under the changed conditions, just as a different aspect there.
Yeah, thanks, Matias. I didn't mention explainability, but explainability is all part of this as well. You're absolutely right, because if we can trust we understand the model, grasp what it's doing, it will make us trust it and maybe understand what it's going to do through a crisis period. Yeah. I'm not sure, the question about defaults within a 12-month window, I mean, having long windows to measure defaults is always a problem, regardless of crisis or not. I don't know, I'm guessing I might answer by saying, you know, use a 6-month model as a proxy for the 12-month, but that also raises problems, of course. Okay, so the next question's a nice short one. How do you define when in crisis mode? So Matias, do you want to start with this one?
I haven't really thought about that, because somehow that is very obvious in the current situation. But it's almost, there's no black and white answer. So at the moment we know we're in crisis mode, but there are all these steps in between, the gray area, the fuzzy area, where you are in a sequence potentially of mini crisis, and then you need to react to it. So I would define crisis mode via a set of metrics. So the contract that I referred to, this is when the model is well within its normal, if you want, way of operations. The inputs follow certain distributions, the outputs are as we expected, the accuracy that we monitor regularly is within acceptable bounds. And as soon as we get out of it, we are potentially in a crisis mode. And then it's the judgment of the human supervisor, if you want, that will decide, is it a mini crisis that can be easily tackled, or do we need to do something more substantial?
Okay, thank you. Michael?
Yeah, I mean, I just maybe would add that there's crisis mode. I mean, it's quite visible to everyone in the world at the moment. We're in a crisis. But you could also consider crisis mode to be purely on algorithmic terms. When is your algorithm in crisis? When is it deteriorating? I think we've touched upon some of those ideas already, and in some cases it's just going to be perfectly obvious. But I could also see a use case. There's a big trend towards AI on top of AI, for want of a better word. I can see a use case for AI models that are particularly designed to identify when models are losing accuracy, or when models are at risk of needing, or on the risk of becoming in crisis mode and needing recalibration.
Yeah, thank you. So, I mean, I'd also follow on from what Matias said earlier, that, you know, obviously this crisis is quite visible, but there may, you know, there's always population drift, and it may be for your specific application, there's something going on which isn't in the news, maybe, but is affecting your model, and, you know, having substantial population drift for your particular application. So you should always be cautious and conscious of that. And really the only way of spotting it, I think, is in monitoring. So if during your monitoring you're seeing, your population stability goes crazy, or your model performance goes a bit crazy, then that's when you realize that something's happened and you need to take some sort of remedial action.
Yeah, perhaps a good example is a well-known one is the Google Flu Trends algorithm.
Yeah.
Performed fantastically and then performed terribly. I mean, that's not obviously a crisis, but it's a crisis for that algorithm. And
yeah,
earlier.
It's probably also worth mentioning, often we have only one model deployed live that does all the prediction, but there is obviously always scope for approaches where you have multiple competing models on there, and you could make the case, as long as they closely agree what the outcome, what the situation is, you're probably all right. And if they're very different and have different strengths and weaknesses, that would be a good indicator if they suddenly start to diverge in the way they behave and that outcomes, that you have hit an unusual situation.
Okay, thank you. So the next one, sorry I badly worded my question. Maybe I should apologize because I misunderstood it. But okay, so the question's repeated. If you are using previous crisis to model a current one, do you run the risk of double counting, etc.? This is because the effects of the historic crisis are already present in the modeling data and so accounted for. So Matias, you want to start with that one?
No, I don't think you're necessarily double counting, because you make a conscious decision when you build a model what your training data set is. So if the current model doesn't have input from the current crisis, it has only historically. So you make a conscious decision there whether you include a historical crisis several years back in that training data or not. Now, once we are through this crisis and then have a need to recalibrate the model, to review it, again, you make then the conscious decision, is the crisis actually the new normal? Some of the things, so things like working from home might well become much more common going forward. And if that's a key input into some of your predictions, then you would adjust your training data set. But I don't think you're necessarily in danger of double counting. Okay,
Michael?
Yeah, I would just maybe talk about, I think, a general problem in the machine learning community, and the next step really for my mind in terms of AI. And that is, as Matias talked about earlier, when you have any AI model, it is really, really good at predicting right now, otherwise it wouldn't go into production, quite good at predicting a short time forward, but almost invariably will drift and will become poor at predicting eventually. I think there is a big need and a big requirement for AI algorithms to be able to capture more of a long-termness, essentially, and be able to evolve a bit more in that way. And I think there's a lot of work in that space of really, in a sense, decoupling the algorithm from the training data, and how we can augment and expand and transfer and self-learn, and things like adversarial networks play a role in that. So I think that there is kind of hinted in the question, there is a problem in AI automatically in really accounting for longer term trends and longer term effects. But I think that's something that there's a lot of interesting work in at the moment.
Okay, thank you. So we've got about four or 5 minutes left. Let's see how many questions we can get through. So the next question is, at the moment, the challenge is that we are not predicting through a crisis, but during a crisis, with imperfect or pre-crisis data sets. Seems to be like little alternative in this context to the judgment conservative approach. This puts a premium on existing models being well supervised and interpretable. So it's a comment, but Matias, do you want to say anything about that view?
Absolutely, and I think the premium shouldn't just exist in a crisis mode. I made a case earlier, that is something you should have in place all the time, because it's very visible right now, but it can happen completely hidden from you anyway through all kinds of reasons. So yeah, fully agree with that statement.
Okay, Michael?
Yeah, I don't disagree either, and again, would champion interpretability. The only point I would make is I think it doesn't mean it always needs to be this way, and I believe that there is a future for AI where we can incorporate some of this uncertainty and so on into the actual modeling approach and build more robust models to these kind of environments.
Okay, thanks. I don't have much to add apart from practitioners I've spoken to in credit risk or in model building. You know, at the moment they seem to be in this frame of mind that they're going to use expert judgment and conservative approaches. So I have problems reading the screen because a message comes. Okay, so how we use machine learning algorithm in the efficiency analysis. I'm not quite sure I know what efficiency analysis is, but maybe Matias or Michael. Matias?
I'm not sure either what that refers to.
Yeah, I'm not entirely sure what context efficiency is being used.
Okay, so if the person putting the question up can clarify, maybe we can get to answer it. Okay, let's go to the next question. A crisis implies changes in the structure of the data, but it may take long to realize. When will you sample again to recalibrate your model to the new data structure? So maybe Michael, want to?
Yeah, I mean, I think often with models today, and one of the advances and the killer apps of the internet-enabled world is that there is perhaps less need to sample again because we can often access data as a continuous stream. And I think there's a lot of work in kind of ML ops kind of space whereby models automatically relearn and retrain on a timer. I think it just reinforces the need for this to be viewed not as a one-off process, but as an ongoing process in terms of modeling and training the model.
Yeah.
Okay, thank you.
It might take some time to periodic relearning and so on, but I would hope if you have proper monitoring set up, then if the model is actually used for predicting in the real world, day in, day out, that you very quickly will notice if there are drifts in the input data, the information that you put into the model to get an outcome. And those things, because that's when the model's actually used, you should notice quite quickly. So it's not unusual to have, for instance, dashboards that show you the distribution over for summary information each week. So after a week, you would see that the distribution has drifted significantly, and you then make a judgment call as a human supervisor. Is that just a fluke? Might be some random noise in there, or is there something significantly that has happened and you need to take action?
I think there's also the potential, and I think it was touched upon in Tony's conversation, is building models that weight more strongly data that's been collected more recently into their model, which can help alleviate that problem as well.
Actually, okay, thank you. So we have to finish there because we have to finish dead on time. One of the last questions, not a question, but sounds like that we need to work more together with the computer software engineers developing machine learning and artificial intelligence. So that's quite a nice way to finish the session. So thank you for that. So just very quickly, thank you to Matias and Michael for joining us as panelists. It's been a great discussion, I think. And thanks for everyone attending today's session. And we're finished now. Thank you.
Thank you.
Thank you, Tony.